These notes are on the differences between linear, exponential, and quadratic functions. So we talk about rate of change for all three of these functions, and we talk about them in slightly different ways. The rate of change for a linear function is constant, and what that means is that if I go from one point and I go 1 over, that's going to be the same rate as when I go from here 1 over as this rate here. That rate doesn't change regardless of what 2 points I pick. As long as I reduce the fraction, they will all be equal. The equations for these have a highest term that is x. So you have seen equations of this type written in mx plus b form. You've seen them written in standard form. And you've also seen them written in point-slope form. Either way, any of the ways these are written, you'll see that the x, the highest power on this x, is a power of 1. And we don't write that because it's a nicety. We've assumed that everyone understands that power there is 1. So the highest term is an x to the 1, if we're going to be very careful about that. Now, for exponential functions, our rate of change, we can talk about it in two ways. In Math 1, we often talked about it as being a constant factor. It turns out that exponential is a little bit extraordinary because the rate of change is actually an exponential rate of change. It turns out that if I just keep finding rates of change over and over and over again for exponential, those rates of change will continue. Each time will still be in the pattern of an exponential. For exponential equations, for the graphs, they have this general shape. So they flatten out someplace and then they continue getting higher and higher on the other side. For exponential, the equation, x is an exponent. So that means I could have something like y equals 3 to the x, or I could have f of x equals 1/2 times 4 to the x. Either way, the x in the equation is an exponent. The last function that we're looking at and comparing are the quadratic functions. For the quadratic function, it turns out that the rate of change is linear, meaning the second difference is constant. So when you're looking at a table, you have like a quadratic relationship, and when you look at the first difference, it's a linear, and when you look at the second, it's a constant. It's the same number being added or subtracted every time. In this case, for the graph, we have a parabolic shape, which we call a parabola, and it's a U shape. And it can be a U going up, a U going down, it can be a U moved over, up, anywhere. For the equation, the highest term is an x squared. So you could have y equals x squared, or you could have y minus 4 equals 3 times x minus 4 squared. So when I multiply this out, I'm going to have an x squared, and we'll look at that further in the course of Math 2. Let's do one more example. So y equals 1/2 x squared minus 4x plus 10. All of those are quadratic, represent quadratic and parabolas.